I was trying to get a new equation with a leading coefficient of 0. Wait, leading, I must have been in the first column. Leading, oh, I was getting this one, right? And how did I get this one? I was doing elimination with the established 1. That's a snazzy way of saying it. The established 1 in the column, identity matrix. Established 1s we're trying to get in the main diagonal, all 1s. Row echelon form would say 0s below. Reduced row echelon says a full identity matrix with 0s above and below. But I have that on the next page. I just copied and pasted to show you guys the difference between the two terms. But right now, we're just trying to finish this matrix. I already started getting 0s in both places, so we're going to keep on going towards reduced row echelon form. And then we'll finish off the problem and kind of recalibrate and see how we're doing. So, this was me over here, sorry, off to the side, doing this step right here. Let me do a different color just so that you can see it. It was me actually doing the math that led to this solution. It was me doing the math of taking equation 1. And remember, it's not equation 1 necessarily from the very, very beginning. It's row 1 from the matrix right above. So I took row 1, I doubled it. Actually, I multiplied by a -2, multiplying each entry in the entire row by -2. I took row 3 and I added straight down. But then I started doing mental math. I wasn't showing all of my work. But is there anyone I lost yesterday that wants to talk about any of the steps we've done thus far before we move on? Yeah.
So for each one that is like this, like, are the steps going to be pretty much the same for each?
Very similar.
So like as far as
because we're thinking as a programmer, right, and trying to find like the system. So what were you gonna say? So as far
as like R1 plus R2, like the same steps like each time.
Yes, except we don't have to be a complete computer, which means there is going to be some variation here because we're actually looking at it and making it happen.
And then as like which like numbers are we trying to get rid of? Like is there certain?
We're trying to get to that identity matrix from yesterday. This guy. We're trying to get all the variables. So this is remember this is an augmented matrix, which means we have like all the variables over here, like the x and the y and the z. This is a square matrix, three unknowns, three equations. We have to have 3 for 3.
Okay.
But that's not all we have. It's not just that. We also have these answers, which is going to lead us to a solution for the system. But we're trying to get the variables to be an identity matrix of 1x equals 1y equals 1z equals 1w equals. So we're trying to get 1s here and 0s everywhere else. Now,
is that going to be like possible?
Most of the time. Remember how there are some no solution, there are infinitely many ones? If there are no solution, infinitely many ones, this isn't going to get us all the way there, but it will get us partway there. Okay. What this will solve, if it works, and if we can get 1s and 0s everywhere else, is we will have the x, the y, the z, the w, whatever we need for that one point where they all intersect. Okay. But we have to start in each column, getting the 1 first, and then getting that column's 0s. Because we're going to move on to another column, still doing operations, and if we don't move in this order, if we say get the 0s across first, as we go down here, we're going to end up messing with the 1 right above. If that makes sense. So we go column by column, getting the 1s first, the established one, and then using that to get the 0s. That's kind of like the program, the systematic approach. And then we get the 0s. And the way we get the 0s is what you just noticed we do elimination. Sorry, Sophia.
It's about the homework.
Can we pause and get back to that? Just because we haven't even finished like one full problem. Then we're going to talk about terms, and then we can go with it more.
Just about like how we do it. Like if we use the whiteboard, we're not going to get things off.
Well, but check it. The whiteboard isn't like eliminating all work. Does that make sense? It's just eliminating the mental math that goes in between getting from here to here. See what I mean? So you'll have work. And to be honest, my head wouldn't write that down. Like if this was my homework like in college, like in linear algebra, the very beginning, I wouldn't be writing that down unless it's not matching. Then I might slow down. I would be doing it kind of like I did yesterday when we were all working together, and I was just doing it like with mental math. But see how there's still steps to show. But great clarification, thanks. So you're coming back. Where are we at? We have gotten to, first column done, second column done. What's it now? What do I need to get?
0.
I need to get my 1. Establish the 1 and use it to get the zeros. Establish the 1 and then use it to get the zeros. That's a great trick to write down. Now establishing the 1, wait, how do we find the 1s in all the other ones? How do we find the 1 in the first? Oh, he was already there. How do we find the 1 in the second one? Oh, we just multiplied by a negative. This is the first one, the first column that hasn't had some variation of 1 to begin with. So, you know how we were, I'll use your terminology, Jane. We were like adding and subtracting, we were multiplying and doing elimination to get zeros, right? To get zeros, we eliminate. To get 1s, we divide. And if you were a computer, I would actually have gotten 1s at the very beginning. In some way, shape, or form, I would have divided everything to get 1s because computers don't mind fractions, humans do. But at least for you guys right now, to get a 1, we have to divide right here. What we're going to divide by is just whatever's there. To get 1s, we always divide. And the nice, oh sorry, I put row 6. And the nice thing is, if we divide zeros by anything, does anything change? 0 divided by 6, still 0. Good, I needed that. 0 divided by 6, still 0. Good, I needed that. That's why we do these first. 6 divided by 6 is 1. What's 12 divided by 6? Ooh, you guys are lucky. This is a pretty one. No nasty fractions yet. Yeah. 12 divided by, I don't think there are. I think this is a nice one. They're coming. But anyway, 6 divided by 6 is 1. 12 divided by 6 is 2. Sweet. And I have the rest of them because I was just establishing my 1. Establish 1, check. Once I get my 1, what do I go get if I'm trying to do reduce? 0. 0. 0. How do I get 0? I eliminate them. And how do I eliminate them? Meaning negative 2 and negative 5. I take that 1. I take that row 3 and I say, you know what? I'm going to use you. I'm going to use the 1, and if I'm needing to eliminate, I'll multiply you by the opposite of whatever's there. Which you could tell a computer to do. Just take this constant A, B, C, D, E, F, G. Take G, multiply this by negative G, and then it will always cancel.
Wouldn't you get a 0 then?
I want a 0. Here and here. I'm going to get a 0 by multiplying row 3 by 5 and adding to row 1. I'm going to get a 0 there too. I'll get my row 2, I'll get my row 1, and I think I'm going to be done. 0, 0, 1, 2. He was good. I'm not changing anything. But I'm using that established 1. I'm going to pause. Because right now you could go onto your scratch work, right? And couldn't you go ahead and say, wait a minute, I need 5R3 plus R1 to add to get to my new R1. So I'm going to take what's right up above, times 5, wait, 0 times 5, 0 times 5, 1 times 5, 2 times 5. I'm going to add that to row 1. So 1, 0, negative 5, negative 3. I get 1, 0, 0, 7. But my mental mathers, that's one way. That's one way. The other way is just to take it term by term and say, okay, 5 times each term. 5 times 0, 0, plus 1, got it. 5 times 0, 0, plus 0, got it. 5 times 1, 5, plus negative 5, got it. 10 minus 3, 7, got it. Go off to the side, do elimination with all the numbers, or you can try to get down the mental math process. No shame in either way, both ways work. So pick a way and get me the second row, because part of homework is little shaded boxes that say, if the row operations were done, what would be in this box? I've just given you a whole blank row. What would be in that row? Take a minute or so. I don't know. You fill it in. Go off to the side and do the operation. 4. Try to do the mental. Your sister just texted me. Yeah, she thought she saw my dog and she was like, it's Jeff. And then she's like, oh, this is teaching. Come here with what? You guys got it? Did you go off to the side? That works. Did you try to do a mental math? That works too, maybe? Who are you multiplying by 2?
The bottom.
Yeah, this guy or this guy. It kind of helps to come up here because you're adding to him. I think it kind of helps. This one, you have to like jump up. So you're doubling, right? So 2 times 0 plus 0. 2 times 0 plus 1. 2 times 1 minus 2. 2 times 2 minus 2. Wait, we're done though. Exactly. Wait, we have the identity matrix. Exactly. Wait, what does this mean? Didn't this come from x's and y's and z's at the very beginning equaling constants? So don't you now have a system of equations where 1x is equal to 7, 1y is equal to 2, and 1z is equal to 2? We're done! 7, 2, 2.
Oh my God.
All by playing with numbers in a very legal way. But all by playing with numbers. I'm going to show you some terms and how this relates to row echelon form and how this relates to the stair-step method. Because we're doing a stair-step method, but an extreme stair-step method where we're not just getting rid of this, all of these guys below, the x's and the y's, but we're getting rid of all of this as well. We're kind of going above and beyond. But the above and beyond gets us straight to an answer, which is really, really nice. But pause. Did anybody get stuck on this row? You kind of have to train your brain to do it mental math style. And once again, I've had multiple kids that have just chosen to have a whiteboard and they always do it off to the side, or they always did it off to the side and they got it right. So it's up to you as to finding the way that works for you. In honors and in regular. There was no shame either way. And to be honest, as I said before, if you go off to the side, the odds of you getting it right will be much higher than the odds of us mental mathers getting this right. We're just going to be like, we got it faster, and you'll be like, you got it wrong. Like, okay, so just make sure you're getting it right. Now, let me show you some terms, okay? I'm going to use like the book for this, because these problems take some time. So hold on first. Have you seen row echelon before?
Yes.
Yes, because row echelon was a form of a system of equations when we got it to be in a stair step, right? But that stair step would look like some sort of AX, and then you would have some sort of, let's just do A1, B1, C1, D1, there we go. Then you would have some sort of like B2, and then you would have some sort of like C3. Wait a minute, but didn't I tell you guys that technically the form was to get everything with a leading coefficient of 1? So didn't I have you like dividing everything to get him just to be a 1 instead of an actual number? Or dividing to get him to be a 1, which you would have had to divide. I'm just showing the idea. Dividing him to be a 1. Check it. Wouldn't that have been in matrices? Wouldn't row echelon form have been 1, 1, 1, 0, 0, 0? Just with, I don't know, some sort of other numbers up front? This is row echelon. Now, what do you notice about that and what we just did?
There's ones and there's zeros, and there's zeros.
Right? There are zeros below, not above. Does that help? Leading coefficients of 1, the very first coefficient you get to in each equation is a 1, and zeros everywhere below, but you can have numbers above. The very first coefficient you come in each equation is a 1, zeros below but not above. That's row echelon form. Why was this good? You can get, well, not the answer right away, but you would have the z to plug in to get the y to plug in to get the x, right? You could get the answer with back substitution pretty easily. But question, what's the difference between row echelon form and reduced row echelon form, which is what we just got? What did we just get?
You don't actually have to do any actual math, you just plug it in.
You just keep going. Now, you guys saw on your calculator yesterday that there was like a little bracket by the A that you were making, right? This is a matrix, this is a matrix. If you get 1x equal to 1y equal to 1z equal to, do you know what x and y and z are? Man, life is a lot easier, right? Except what you're doing in these matrices is you aren't going from here into here. You're actually going to get the original equation in, and then you're going to try to make it look like what you want. So even though we were kind of going this way, we're going to go the other direction and say, if we can get that, we can solve with this. But if we can get this, we'll know x, we'll know y, we'll know z. That's the difference between reduced row echelon and row echelon form. But guys, Jaden asked a second ago, he was like, wait, will this always work? And what did I have to say?
Most times.
Remember systems of equations, what could go wrong?
Parallel.
Parallel, which means no solutions, but what would your system do that showed you no solution, impossible, cannot work? No, that was true, that always worked. Yeah, two different things equal each other. 0 equals 7. No it doesn't. Oh, no solution. Could that happen in a matrix? Yes. But how? We're going to see it in a second. What else could happen? The true statement, Sophia. What happens if 0 equals 0? How many solutions? But don't we have to let z equal a and then do like a formula? Okay, that could happen in matrices also. But if that does happen in matrices, can I show you where it's going to go wrong? You're going to try to get an identity matrix and something fails. Like you can't get a 1, or you only get zeros, or something's going to go wrong. And you're like, well, it can't go wrong because we're the ones doing it. Oh no, it can go wrong. Not wrong as in you're doing it wrong, but wrong as in you're like, I want my 1s. And it's like, nope, not today. And you're like, oh, okay, something's wrong. Is it a true one or is it a false one? Is it a true one or is it a false one? Guys, I do have like a lot of, just in case there is one of those weird ones where you can't get it, it's going to look different and maybe still be in its row echelon form. It just might not be the pretty row echelon form because it's impossible to get all the way there. It might be in its reduced row echelon form, just maybe not the pretty reduced row echelon form because it can't get all the way there. Those funny no solution or infinitely many solution ones, they're row echelon or reduced row echelon forms are going to look a little funny, but there is this chart in the book that lets you know whether or not how to compare those weird ones that don't look normal. Let me show you a couple examples fast, okay? If we were to go into the book real quick, let me go up one. Here we go. Here is, wow. If you were to see this in section 7.3, would you have been scared with x's, y's, and z's, and w's and 4 equations? Because we would have had to, okay, calm. We would have had to have taken these two and eliminated x's, these two and eliminated x's, these two and eliminated x's. We would have had 3 equations to then eliminate y's with, and then eliminate z's with, and then z's with, and then getting w. We could have used our system. It would have been gross, with a lot of rewriting of a lot of variables. Matrices say, nah, it's all right. A lot of rewriting, but only the numbers. It'll save time. And if you learn how to use a computer and how to program, you can have it do it for you. But you have to know the system first. Because we don't want you guys just to be the ones using computers today, or tomorrow, or in all the tomorrows ahead. We want you maybe even like designing them to do new things. You have to understand how they work, at least a little bit. So with this system, this is what they call, ready? Gaussian elimination, we talked about that already. Isn't Gaussian elimination just row echelon form?
Yes.
Okay, so Gaussian elimination is row echelon form. Check it. How far did they get? Did they get their 1s?
No. I mean, yeah, but...
Yeah. Did they get the zeros below? They just didn't do the extra step of getting zeros and zeros, 0 and zeros, 0 and zeros. They just got the 1s and the zeros below. It actually wouldn't have taken that much more work to get the zeros above, but whatever. what's nice? Well, now they have a nice little stair step to say, plug in, solve, plug in, solve, plug in, solve. Like, you can do it. It's not that it's impossible, and you had a lot of getting zeros that you ignored. Row echelon form, Gaussian elimination says get to a stair step. Get to a stair step, get your ones and zeros below, get to a stair step, and solve. But what's the next page? Gaussian elimination. Something could go wrong. Okay, we'll get back to that. But what's this one called? Gauss-Jordan elimination. If you guys want to see who it's by, it's after Carl Friedrich Gauss and Wilhelm Jordan.
Oh, it's different Gauss.
No, same Gauss as the other one. Just Jordan is the other guy. He gets to be brought in.
Who's Gauss?
Oh dear. If you guys notice, this is what I just did with you. This is reduced row echelon form. Why not just go all the way? And why not just get your unique solutions if unique solutions exist? So, Gauss-Jordan, go the extra mile. Oh, hey, there's an extra name. Gauss-Jordan, go the extra mile. Go the extra distance to get all the way there. Gaussian, it's okay. Just go part way. Do you guys want to see, though? Do you see the no solution? Do you want to see what could go wrong? Well, don't you need to be able to recognize it, though? Okay, so what could go wrong? You have your system. You make it into a matrix. You say, okay, I'm going to get my 1. Got him. I'm going to get my zeros. Ha ha. I'm going to get my 1. Got him. I'm going to get my zeros. Ha. What happened?
A 5.
Wait, everything went away. Isn't this the 1x, the 1y, the 1z? It's gone. Question, can 0x plus 0y plus 0z equal negative 2?
No.
No, 0 plus 0 plus 0 is 0, not negative 2. Is this a false row?
Yes.
A false statement. Ah, we can stop. You could have tried to keep going, but you can stop. If you can't get the 1 there because everything just canceled out, well, I guess you're done because that's impossible. So what was the final answer?
No solution.
Thank God.
It's just going to look a little different. Then we would go ahead and bump this guy up, boop, and we would let z equal a at the very bottom. So we would still go all the way, but we would have to go ahead and plug in a and then plug in a to get our final solution. You don't like that? Or you don't get it?
No, I don't.
Oh, yeah. Sophia likes it, though. To each his own. Coming back. Boop, boop, boop. So, oops, I don't know what I undid. Sorry, those same time. So the best way for us to take like little short baby notes on this is if we start with a certain matrix, if we're going to row echelon form, we would go here with some sort of, I don't even know what, whatever is in this spot, the first row, second column, getting our, I don't know what this will be at that point, but it'll be something different. Remember, it won't be the same numbers that will have been row operations performed. But this would be stopping at row echelon form of my matrix A. And if I keep going, however many steps I need to get 1, 1, 0, 0, now all of a sudden, I don't know where I'm at, but I'm somewhere. Now I will be at my reduced row echelon form. This one says go put it in equations and solve it. This one says, oh, you're already done. 1x, 1, 1. So Gauss-Jordan says keep going. Keep going. Extra name, go the extra steps. Extra name, go the extra steps. RREF. So we're going to go play with the big old system. You guys ready?
Sure.
Figure out what you want to do. Do you want to do scratch paper? Woo, look at this guy. Do you want to do scratch paper? Okay, we just want to go for him the way he is.
I'm not gonna do something.
Oh, come on. Would you want to do this the 7-3 style?
I would rather just not do it at all, to be honest.
Oh, well, I don't think that was one of the options.
Yeah.
Okay. Nice thing is, believe it or not, when you get to pre-cal and calculus, hopefully you get really solid in your fractions, in your addition and your subtraction, in your complex fractions, in your factoring, and wait, isn't that all the stuff you learned in like algebra and pre-algebra?
I'm very comfortable, very confident that I don't like them.
Let's make them. Wait a minute. We're humans. Since we're humans, do you guys remember how we're allowed to interchange things? Does anybody want one of the other equations to go on top?
I want the one.
Caitlin, which one do you want to go on top? Second or fourth? Why did I ask for a second or fourth? What do you want in this spot?
A 1.
Okay, so we're going, we'll all go the same route. Fourth? Fourth. So we're going to make 1, 1, 1, 1, 6. So on top. We're rearranging these.
Wouldn't it be better to put the second one on top and then the fourth one in the second one?
You can technically go your own route, but if you go your own route and you make a mistake, you won't be able to see it until the end. Well, remember, we have to go get zeros anyway.
Oh, okay.
And then we have to go get the 1 and then the zeros, so things are going to change.
Oh.
It's a good idea, but things are going to change a lot along the way.
Why did you? Oh, it's 1.
Because we want the 1.
I thought they were different.
We're going to keep the rest of them? Is that okay as a class? That way, if we're all doing it, if you make a mistake, you'll catch it. Where are we at? Oh, this guy. 3, 2, this black's going to annoy me. It's going to be a different color. Whew. If you guys don't mind, I'm going to try to go across and not just straight down. If I go straight down, I'm going to run out of room real fast. So I'm going to try to fit mine in across, and I believe most of your paper would be able to fit it across too, meaning I'm going to get this one and go here, and then go down, and then go across, and then go down, and then go across. Is that okay? Yeah, I heard my name. Yes. Let's get my numbers first. Okay, dotted line. Because we are keeping our square matrix separate. This is our identity. We're trying to get 1, 1, 1, 1. But remember, before we go on to the next one, we got to get what?
0.
Zeros in all of these. And how do we get zeros?
Reducing.
Eliminations. Right? I'm going to use, yeah.
Which row did you use?
I'm going to use R1. And I'm going to be adding in all of these. I'm going to be adding R1s, which is where my established 1 is, to row 2, to row 3, and to row 4. But I need this addition to cancel out. So what do I need to multiply this by to make him cancel? A negative 1. How about to get this guy? An opposite. So you're always doing the opposite times this row plus. You're always doing the opposite of the term times the established 1 row plus the one you're trying to get into. So that's going to be a negative 3, right? Getting into a new row 4, getting into a new row 3, getting into a new row 2. Do you understand the direction I'm headed? So if your mental math's not too shabby, try to get ahead of me and then double check with me and we'll make sure we're right. I'm going to make my marker thinner because I don't know about you guys, but this thick marker is not going to work well with me trying to write things smaller than before.
I'm drinking a lot of water.
No, you're good. It kind of makes sense.
Oh, yeah.
Bless you.
Hold on, get ahead of me, unless you're like, nope, I can't do mental math.
I think you did. But I am mental.
Oh, that's weird. Huh?
No,
Yeah. You said you how could you throw black and nothing?
Alright.
You had newsflash. You're gonna
The likelihood of you making a mental math mistake while talking is very high. With me every day in class. Okay. How was that? Negative 6 plus 25. We all get 19? How was that 14? How about that negative 18? Now pause and check the rest of everything that I row. Make sure I'm right. Make sure you're right. You should match up. All of us. If all of us match up, what's the likelihood of us doing it right?
Higher, exactly.
Now pause. Those of you that are going a little slower, it's totally fine. Okay? I'm just curious, are you getting at least the first row? Okay. If you're getting the first row, then keep going your route. You should get the second, you should get the third. And you should be ready with the rest of us once you get there to move on to the next goal. What's the next goal? Aww. Hey, we're humans. You want to switch up? What happens if we switch these two? And multiply him by a negative? Now, could we divide by 2, divide by 2, divide by 2, divide by 2?
I would not.
Do you want 19 over 2 to be?
No.
Okay. So what we're doing next is, Jane, we were going after getting a 1 right here, but we noticed there was a 1 right there, and we're humans, we can kind of, put the 1 that we want in the spot that we want it. We're going to change those two equations. And let's not just change the two equations, let's multiply by a negative. But as we do that, someone had a question. Emma, was that you?
Of course you did.
Slow me down.
No, it's so stupid.
So I'm going to do
No, I did something stupid.
R2 switching with negative R4. Does that make sense? Everything else is going to stay the same. So I have my 1, 1, 1, 1, 6 still. I now have a 0, positive 1, positive 4, positive 2, positive 18. Now guys, you realize, don't you, we didn't have to do that. We could have gone with the nasty numbers. If we were a computer, it would have been like fractions. Fractions are my middle name. But us, we're like, nah, let's go get that nice one. We're keeping that 0, 3, 4, 1, 14. But then we're moving that row 2 down here. 0, negative 2, 3, 1. But long story short, have we gotten our established 1 in the second column?
This is honestly a dipole moment. A dipole moment.
Right?
Unequal share.
That's a vocab, yeah, it's a vocabulary of the test.
Oh,
Well, you guys all laughed. I assumed it was some sort of like meme, but instead it was literally just like, no, look at dipole. Okay. Hey guys,
The molecule itself.
why am I going to multiply and add row 2 this time instead of, not there, instead of row 1? Last time I did row 1. Why am I doing row 2 now?
Because it's already.
Because it's
row one's already done.
zero.
Row 1, the 1's already done. Where am I in column 2 now?
Define zeros.
I'm finding the zeros using the established 1. Where was the established 1 in column 1? Row 1. Where's the established 1 in column 2? Row 2. I'm going to be adding to row 1. I'm going to be adding to row 3. I'm going to be adding to row 4. But hold on, I need these to be zeros, so don't I need to eliminate?
Yes.
So to eliminate, hold on, what do I need to multiply this 1 by to get him? To cancel. A negative 1. A negative 3. And a positive 2. We're always doing the opposite of the entry that is there. Multiplying it by wherever the established 1 was. The old 1 was in row 1, so I was multiplying the opposite by that 1 and adding. The new 1 is in row 2, so I'm multiplying that and adding. Jaden.
Why did you switch?
I was being lazy. To get this to be a 1, we would have had to divide by 2, and all of a sudden we started seeing fractions that we didn't want.
Oh,
So we were like, that already has a 1. That's just a...
that's not lazy.
Could have divided by 2. Could have divided by 2. So which row is staying the same as that second one, right? Yes, if you're loving this, you might want to look into either computer programming or accounting. Or actuarial science, maybe? Actuarial science has to do with being the mathematician behind the insurance companies, which is good. So I'm multiplying times a negative. 0 times anything is 0. Plus 1. Oh yeah, that's why we wanted the zeros, is so we don't get thrown off from here on out. Negative 1 plus 1 is 0. Sorry, I'll be quiet. Negative 12? Negative 40? Yes, 3 times 18 is 54. Negative 54 plus 14, I believe, is negative 40. 2 times 0 plus 0, 2 times 1 minus 2. 36 plus 19 is 46. I believe it's 55. Double check.
This is San Diego or something.
Now, some of you were like, I'd rather do the equation 1, equation 2, get rid of x's, equation 2 to equation 3, get rid of x's, equation 3, equation 4, get rid of x's. Now let's go for the y's. If you want to. I think I do too.
Can we just watch the matrix move instead of doing this?
Nope, good job.
Keanu is waiting.
We have to go for the next column. However, if you're going slower, it's okay. Take your time. But did you get at least one row? And go slowly. You should be able to get the rest. Now, hold on. Where do I need to get a 1 next? Don't I have to divide no matter what? Either divide by negative 8 or divide by 11? We have to divide either way. So let's just go with the one that we have and not have to switch it. Is that okay? So I'm going to go ahead and keep that third one the way it is. But I have to get it to be a 1 and get it with division. Please don't try to get it with subtraction or addition. If you do, you very well may mess up your zeros and you mess up your whole thing. 1s and zeros, leave these alone. Either do elimination to get zeros or do division to get 1s. Don't do any other operations unless you're switching. Meaning, I'm going to multiply that third row by negative 1/8. Only negative 1/8 will get me the 1 where I need it to be. 0 divided by anything is 0. Whew, he's still there. 0 divided by anything, exactly, that's why we're dividing. Negative 8 divided by negative 8 is 1. Oh, that's 5/8. That's gross. But, negative 40 divided by negative 8 is just going to be 5. That's not all bad. The rest of my guys do the same. So I have 1, 0, why am I don't get it. Okay. Negative 1, negative 12, 18, 2, 4, 1, 11, 5. What do I need to get next? 0. But where or how am I getting the zeros? Using which row this time? Third row, because that's where my 1 is, yeah? Which ones am I changing? Yeah.
Why don't we have to get 11 to 1?
Oh, because I'm still in my third column, which I've gotten the 1 for the third column. Now it's time to get my 0. So that guy needs to be a 0. This guy will be a 1 eventually. But remember, we work by columns. We get the 1 first, then the zeros, then the 1, then the zeros, then the 1. Now the zeros. Priyanka, if you had switched those two, you might have gotten the 11 to be a 1. We just kept it where it was. So now we're using row 3. We'll think about the eliminations in just a second. We're using row 3. But we need it to cancel out, right? This guy's going to stay the same. The 0, 0, 1, 5/8, and 5. All right, hold on. I need it to cancel. I need a negative 3 to cancel. Okay, times 3. I need a 4 to cancel. Okay, negative 4. I need an 11 to cancel. Okay, negative 11. Okay, cool. So, here we go. Nice thing is, when you times by 0 and add to 1, anything times 0 will always stay the same, which means we're still going to have 1, 0, 0, which is cool. We're still going to have 0, 1, 0, 0, which is cool. Let's go tackle this third column now. 3 times 1 minus 3. 3 times 5/8. Ew. Now, we have to start thinking about our mental well-being right about now. Because we have 15/8 needing to subtract 1. Why am I going to think about this as negative 8 over 8 instead of negative 1? It makes my life easier. So 15/8 minus 8. 7/8. Oh, I can do that. And 15 minus 12, well, that's 3. Negative 4 plus 4 is 0. Negative 28 plus 16 eighths. Oh, it's negative 4 eighths. That's negative 1/2. I can do that. And then negative 20 plus 18 is negative 2. And then I have my negative 11 plus 11 is 0. Negative 55 eighths plus 40 eighths is negative 15 eighths. And then negative 55 and 55 is 0. Huh. I think that's supposed to help me in a second. What's our last job?
That means it's no solution.
Well, is it though? Good idea, but there's something there. I guess something can be 0. I just need to get him to be a 1. Do I need to multiply that bottom one by negative 8 over 15?
Oh my goodness.
What happens if I multiply it by negative 8 over 15? 0, 0, 0, 1, 0.
Yeah!
That just means that W equals 0. That's okay. No. W equals 0. That's allowed. Now, if it was 0 equals 1, that's impossible. But 1 equals 0, sure. I'm going to keep going. I'll see you guys later. I'm going to keep playing. Adios. Au revoir.
I kind of was not was fun because then I could actually have one, but wow.
Remember, X or Y or Z can equal 0. Just 0 can't equal something.
Good math. Yeah.
See if BC kids think of this fondly when they remember. See Abby's reaction.
Well,
The bus.
oh,
My
you're
reaction
talking
was
about
what?
down there?
Matrix.
Okay.
The bus.
Ah, there we go. That's the reaction.
Yeah.
Yeah. Other people walk.
I mean, I take like.
Yeah, they are. Well, if you like numbers. If not, I guess it'd be scary. Bye, Priyanka.
Huh? Yeah. It's a dream, yeah. I got this. It's the challenge.
I don't want to break your board.
Wait, Kevin, since we don't follow that tip, that means we're all simps, right?
It's all saying. No.
Like, you want to explain it, Kevin?
Like, it's like a guy that would do anything for a girl because he's very
Desperate.
desperate. Yeah.
For a relationship.
It's like you're always like always correct. I would do anything for you.
Isn't that like a white man?
Yeah.
Basically, yeah. Since this is all my thing.
I'm not a
So
Can you guys double check that my solution is right?
What?
Don't remind yourself how to do matrices. You're going to take linear algebra and calculate. I'm going to show you the original solution. I need you guys to see it. It's 3, negative 2, 5, 0. See if I got it right.
I like it, but
The original system was.
Oh, wait, she sent it to the video.
No, I'm talking to you guys.
Oh!
Come
I
on,
like
Macy kids.
matrices, but I don't remember.
Yeah, don't give up.
Do it.
No, just in the calculator. You don't have to do it by hand.
Oh, okay. What do you mean?
I know! Remind yourselves how to do matrices. Can you check whether my solution is correct?
Please, vote. I'm bored. Ryan belongs there. Vote.
Oh, I know.
Vote.
Whoa!
It wasn't any matrices, like that's kind of limited.
Who can remember how to do matrices?
I don't make it though.
In your calculator. R-R-E-F. R-R-E-F.
Be gone.
R-R-E-F.
I don't remember. Where is it? Oh, okay. So
I'm freezing the screen. See if I'm right.
Wait, how many